So let's look at a computer taxonomy. So we're going to look from supercomputers to smartphones. We start with supercomputers. So we start by the ones that have the most calculus power. The fastest and the most powerful ones. These are the supercomputers. Supercomputers are designed for complex, high-demanding calculus tasks like weather forecasting, physical simulations, or crypto analysis, for example. And they're very expensive, and the performance is measured in flops. This stands for floating point operations per second. After supercomputers comes mainframes. Mainframes are computers that are used by large organizations. They're not as specific as supercomputers. And they most of the time are related with massive data applications like bulk data processing, for industry and customer statistics, enterprise resource planning, transaction processing, and more recently the big data analysis that insurance companies do, banks, public administrations and research centers to analyze big amounts of data to get information out of that. So modern mainframes can run multiple different instances of different operating systems at the same time. And this is a technique of using virtual machines, and it allows applications to run as if they were on a physically separated computer. So while mainframes pioneered this capability, this type of virtualization with virtual machines is now actually available on most family of computer systems, although they do not always have the same degree of level of sophistication like mainframes. So what mainframe can also do is they can add or hot swap systems capacity without disrupting system function. So they can do this with a specific granularity that's not usually available in other server solutions. So after mainframes comes the servers, and they're similar to mainframes because they act as a centralized resource provided with high capacity more than desktop computers. The main difference with servers and mainframe systems is that mainframes are oriented to running specific corporate applications like these big data analyses that we spoke about before, and servers are more focused on sharing resources. So like, for example, offering storage, internet access, computing powers, or databases for users. So servers offer these services to their users. The range of prices and computing capacities is broader in servers than in mainframes. You can find very small servers that have capacities and prices that are not much higher than that of a high-end workstation, and mainframes are always powerful and expensive computers. So nowadays most internet service providers are provided by servers that provides web pages, email, databases, storage, and so on. So both mainframe and servers are multi-user machines, and this means that they attend simultaneously several users. So typically much more than the number of processors they have. So what they do in order to achieve that is use a technique that's called time sharing, and we can see this a little bit here on the slide. Basically, time sharing consists of assigning the resources of a machine to one user, but during a very short period of time. So the computer changes this quickly among active users, and it does it so quickly that to the user it gives the sensation that the computer is actually only dedicated to the tasks that they want the computer to do. But it's actually not true because it's doing tasks of many users, and this is what is called multitasking. So most of them have several processors working at the same time and access into shared memory and devices, and this is what is called multiprocessing. So the processors can be assigned to solve different parts of the same tasks, and this is called parallel processing. So in the particular case that a computer executes multiple concurrent processes in different processors, it can also be called multiprogramming. So moving from single-user computers, moving from multi-user computers like mainframes and servers to single-user computers, we have the workstations. Workstations are at the high end of personal computers, and they have very powerful CPUs, lots of RAM memory, and they most of the time come with one or more high-capacity graphics cards. And workstations are typically dedicated to allow for 3D design, engineering simulation, medical imaging, or stock market analysis, for example. So then, after the workstations come the personal computers, that is more for the generic public. And a PC is most of the time a general purpose machine that is designed for end users. They're relatively cheap and they're addressed to domestic and office users, so we do word processing, spreadsheets and presentations with them. So a PC, a personal computer that is suitable for mobile uses, is what we call a laptop or notebook. And actually what they do, they integrate all the devices in a single body with low weight, such that we can carry it around with it. And the weight can actually vary from 3 kilos, and there's even laptops that are around 1 kilogram. And actually they're as powerful as desktop computers, but their expansion capacity is more limited. So basically, they might have less memory, smaller disks, and maybe they don't have all the expansion ports that a desktop computer has. So over the last few years, what we have seen as a replacement for laptops is tablets. So tablets are for users that have even more mobility requirements. Because these tablets are very small, they have a touch screen, and they have very intuitive interfaces that makes us able to use it anywhere. And actually, the fact that they are so intuitive, small, has contributed to their fast introduction. Many people are using tablets nowadays, and it's even being introduced into reluctant sectors. So tablets focus mainly on media consumption, information retrieval, gaming, and online communication. So finally, we have smartphones. Smartphones are smaller tablets, and they're actually handheld computers. And they were born as a fusion of cell phones and personal digitalized assistants, PDA. And actually they nowadays allow us to be permanently connected, and they have a broad spectrum of applications that we can use on them, both from professional and productivity tools to education or just leisure. So other mobile devices that we want to show is the PDA, GPS or portable media players, PMPs, because they're also small computers, each with a specific functions. So a PDA, as we've seen before, it's a personal data assistant. It's a handheld device that was actually made to be a personal information manager. They were very popular at the late 90s and the early 2000s. But they've disappeared mostly because actually all their functionality has been incorporated into what we know nowadays use as a smartphone. But their functions are mainly to store personal information like telephone numbers, notes, photos, songs, and can offer any productivity tool as a calculator, for example, an appointment book, a calendar, and it provides communication tools like email and web access to connect to the internet. Then the other handheld computers is portable GPS devices, also handheld devices that are designed to give the user its current position. And it can help him by providing navigation tools. So also their function have been mostly integrated into what we nowadays know as smartphones, and their popularity has diminished. But they still have a small niche of application for people that do tracking or car navigation. Then finally we have the PMPs, or the portable media players, and these are also handheld devices that are designed to store and play audio, video and digital images in various formats. So they usually store the contents in an internal flash memory or an external flash memory card. And their function has also been integrated into modern smartphones, so their presence in the market has also declined.